Welcome again to Math 800 Pre-Algebra. Today we are doing section 4.7, Problem Solving, Equations Containing Fractions. Our objectives. 1. To use the multiplication property of equality to solve equations containing fractions. 2. To use the addition property of equality to solve equations containing fractions. 3. To use both the addition and multiplication properties of equality to solve equations containing fractions. And lastly, 4. To solve application problems using equations containing fractions. Recall the multiplication and division properties of equality. The multiplication property of equality says if A equals B, then A times C equals B times C. The division property of equality says if A equals B, then A divided by C equals B divided by C, as long as C is not 0. So basically, you can multiply or divide both sides of an equation by the same non-zero number and it will still be the same thing. It will still be equal. And we can do this with addition as well. As long as you do the same thing to both sides of the equal sign, you're good to go. It is very important that you show me that you're doing the same thing to both sides of the equal sign. If you do not show me that work on the paper, you will lose points. Example, solve the equation 1/2 b equals 5. Check your solution. 1/2 b equals 5. Our goal is to get the variable b to have a coefficient of 1. The way we remove the 1/2 is to divide by 1/2. So we're going to divide both sides by 1/2. When you divide a number by itself, it equals 1. It cancels out. Whether that number is a whole number, an integer, a fraction, or a decimal does not matter. When you divide a number by itself, it cancels out and equals 1. However, now we have to do 5 divided by 1/2. Recall 5 divided by 1/2 can be rewritten with the little division symbol, and that dividing by 1/2 is the same as multiplying by its reciprocal, 2 over 1. 5 over 1 times 2 over 1 is 10. Therefore, b equals 10. Again, notice when you divide a number by itself, it is 1. However, we don't typically write that in our answer. Now, it is possible to shortcut this process. We know we're going to divide by this coefficient, the 1/2, but when you divide by a fraction, you always multiply by the reciprocal. So we can simply jump ahead and multiply by that reciprocal. The reciprocal of 1/2 is 2 over 1. Let's multiply both sides by 2 over 1. On the left side, we can regroup using the associative property. Remember, what you have here are three things being multiplied. There's a multiplication here and a multiplication here. When you are doing all multiplication, it does not matter which ones we do first. So instead of doing the 1/2 times b first, we can do the 2 times 1 times the 1/2 first. On the right side, we have to do the same thing. Since we multiplied the left by 2 over 1, we have to multiply the right by 2 over 1. I'm also going to write 5 as the fraction 5 over 1. On the left, the 2's and the 1's cancel out. On the right, 2 times 5 is 10, 1 times 1 is 1, and I get 1b equals 10 or b equals 10. So again, all we did was we shortcutted this process. We knew we were going to divide by 1/2, and when you divide by 1/2, you wind up multiplying by its reciprocal, which is 2 over 1. So instead of doing the division, we just jump ahead to multiplying by the reciprocal. If we check our answer, replace b with 10. 1/2 times 10 is 5, so 5 equals 5. Our solution is 10. This is simply the check. Your answer, though, is b equals 10. Solve the equation 12 equals negative 3/4 x. Check the solution. Again, we're going to shortcut this process. We want to get the x by itself with a coefficient of positive 1. To do that, we're going to divide by its current coefficient, which is negative 3/4. However, to divide by negative 3/4, we are going to wind up multiplying by its reciprocal, negative 4/3. So we will simply skip to that step and multiply both sides by negative 4/3. Notice the negative 4/3 and the negative 3/4 cancel. Also notice how I put parentheses around the negative 3/4 x. Had you simply written the dot for multiplication, the negative symbol visually overrides that dot, and a lot of people mistake this for a subtraction because the multiplication isn't as obvious. When you put it in parentheses, you have a visual clue that you're multiplying, and that visual clue is bigger than that negative symbol, so you're less likely to forget it. So the negative 4/3 and the negative 3/4 cancels out completely. That was the point. And then negative 4/3 times 12 is negative 4/3 times 12 over 1. 12 is 3 times 4. The set of 3's cancel, and we get negative 16. Therefore, our answer is negative 16 equals x. We can check that by replacing x with negative 16. That we rewrite 16 as 16 over 1, and 16 is 4 times 4. The 4's cancel, and we get 12 equals 12. So our solution is negative 16. Solve the equation negative 2/5 n equals negative 1/3. Again, we're going to get the n by itself by multiplying by the reciprocal of its current coefficient, which would be the reciprocal of negative 2/5 is negative 5/2. Multiply both sides by negative 5/2. N is 5 over 6. In this case, there is no simplifying. Notice that a negative times a negative gave us a positive answer. Watch your negatives. If we check the solution, replace n with 5/6. We have some canceling going on, and we wind up with negative 1/3 equals negative 1/3. Now we will use the addition property of equality to solve equations. Solve the equation 1/2 plus x equals 3/4. Our goal now is to remove this constant that's currently on the left side with the x. In order to undo this addition, we are going to subtract 1/2 from both sides. Notice when you subtract a number from itself, you get 0. And 3/4 minus 1/2, we need to find a common denominator, which is 4. Multiply 1/2 times 2 on top and bottom. We get 3/4 minus 2/4, which is 1/4. So I get x equals 1/4. You can check that by replacing 1/4 back in for x, and we see that 3/4 equals 3/4. Solve the equation 2.5 equals negative 1 3/5 minus y. It is possible to do this problem with the mixed numbers, but it is generally easier to work with improper fractions. So I will start by converting to improper fractions. 2.5 is 5/2, negative 1 3/5 is negative 8/5. Now to get the negative y by itself on the right side of the equal sign, I'm going to undo this subtraction. This is a negative 8/5, so I'm going to add 8/5 to both sides. It's not because you're subtracting y, it is because it's a negative 8/5. Those are going to cancel because you have a negative and a positive of the same value. 5/2 plus 8/5. If we do our work, notice how I'm doing my arithmetic on the side. I do want to see your arithmetic, but it's important to keep it off to the side so it doesn't mess up with your equation. Our common denominator is 10. Multiply the first one by 5 over 5 and the second one by 2 over 2. You get 25/10 plus 16/10, which adds to 41 over 10. If you'd like to convert it to 4 1/10, you can, but I personally prefer the improper fraction. We get 41 over 10 equals negative y. We're close, but we're not done. We want our final answer to be a positive y, so I'm going to multiply both sides by a negative 1. On the left, we get negative 41 over 10, and on the right, the negative 1 times the negative y gives us that positive y. So our solution is negative 41 over 10. Now we will use both properties, the addition and the multiplication property. Our first example is to solve 1/3 c plus 5 equals 7. We will start by subtracting 5 from both sides, or adding a negative 5 to both sides. They mean the same thing. We get 1/3 c plus 0 equals 2, or just 1/3 c equals 2. Now to get this to be a coefficient of 1, we're going to multiply both sides by the reciprocal, which is 3 over 1. On the left, that all cancels out and leaves us with 3. And on the right, 3 over 1 times 2 over 1 is 6. Our solution is 6. If we replace that, we get 2 plus 5 equals 7, and it checks out. Our solution is c equals 6. Another example. Solve the equation negative 3 equals 2/3 y plus 7. Check your answer. We again will start by removing this constant from the right side and moving it over to the left side. We do that by adding a negative 7 or subtracting 7 from both sides. We wind up with a negative 10 equals 2/3 y plus 0, or simply negative 10 equals 2/3 y. To get the 2/3 to go away, we're going to multiply by its reciprocal, 3/2. In order to keep balance, we're going to also have to do that on the left side. Multiplying 3/2 times negative 10 results in a negative 15. So our answer is negative 15 equals y. Again, show me the arithmetic for doing your fraction work, but do it on the side of your paper so I can see it, but that it is not cluttering your equation. To check that solution, replace y with the negative 15. We get negative 10 plus 7, which is negative 3. The solution is negative 15. The negative 3 is simply your check. Lastly, solve application problems using equations containing fractions. The expression for finding a person's approximate systolic blood pressure is 100 plus age divided by 2. Suppose your friend's systolic blood pressure is 116 and he has normal blood pressure. Find his age. First, read the problem. Our unknown is our friend's age. Our known is that the blood pressure expression is 100 plus the age divided by 2, and that the friend's pressure is 116. Let's let A represent the unknown friend's age. Then if we write an equation, we have this statement from the problem: 100 plus age divided by 2 is blood pressure. We're letting A be age, and we know the blood pressure is 116. So our equation is 100 plus A divided by 2 equals 116. To solve this, we will start by subtracting the 100 from both sides, and we will get A over 2 equals 16. To solve this, to get A by itself, we're going to have to undo this divide by 2. There are two ways to think of this. One way is to realize this is A divided by 2, and the thing that undoes a division is a multiplication, so simply multiply both sides by 2. Or, and this is really important, realize A over 2 is the same as 1/2 times A. This fact right here is critically important that you understand this. It comes up again and again and again in both math and science classes, and many students struggle with it for a variety of reasons. Whether you memorize it or whether you understand it, I don't care, but you need to know this relationship and to be able to very quickly go back and forth between these two things as being equivalent. The reason they're equivalent is if you do 1/2 times A over 1, you get 1 times A, which is A, and 2 times 1, which is 2. Or you can write it as the multiplication 1/2 A. You need to know that these two things are the same. Now to get the A by itself, you multiply by the reciprocal of 1/2, which is 2 over 1, and you wind up with A equals 32. So your friend is 32 years old. This is your answer. We can check our answer by putting it back into the formula to see if it gets us our blood pressure of 116, which it does. This concludes section 4.7. Your next step is to complete the worksheet for section 4.7. Then check the key in D2L or come to class, and lastly complete the online homework for section 4.7 through MyMathLab.